Hey everybody, Dan Hewitt here, and you're joining me at the Spaceflight Meteorology Group. We're right around the corner from Mission Control, and joining me today is from the National Weather Service is Frank Brody. Frank, thanks so much for letting us come inside your facility today and telling us a little bit about what you do.
Good morning. It's a pleasure to have you here, Dan.
So let's get right into it. What exactly does the Spaceflight Meteorology Group do? What are you guys responsible for?
Well, first, the Spaceflight Meteorology Group is part of the National Weather Service, and we are a special unit focused on supporting NASA's unique requirements for human spaceflight.
So you were heavily involved, I assume, then in the shuttle and every single launch and landing of that vehicle.
Yes.
Tell us a little bit about that experience.
Actually, the Spaceflight Meteorology Group, or SMG, has been here at Johnson Space Center since the Space Center started in the early 60s. So SMG supported Gemini, Apollo, the shuttle, the entire length of the shuttle program from STS-1 all the way through the last mission last summer, STS-135. So we've been here through it all, providing weather support to make sure the launches and landings were safe.
Okay, and what are some of the factors that you guys look out for? I know the shuttle would sometimes scrub for different weather-related things. What kind of weather are you guys always tracking that could affect these launches and landings?
Well, for the space shuttle, that was a very weather-sensitive vehicle. As large as it was and as imposing as it was, it was weather had a big impact on both the launch situation and the landing. So the conditions that we would watch would be lightning. That's a big issue. Low cloud ceilings were a could be a problem, because that way, when either on a return to launch site abort or on the final planned end of mission landing, that way the commander would be able to have time to visually see the runway, because it's just a glider. The other factors that we looked out for were regular rain. Rain couldn't be within a certain radius of the shuttle's launch or landing path. Also turbulence, moderate or greater turbulence was a factor. So, and possibly one of the biggest issues was crosswinds. If the wind was blowing across the runway too hard, that could be an issue with the shuttle landing, since again, it was essentially a heavyweight glider.
Yep. And you weren't only monitoring that weather for the Kennedy Space Center, you also had to monitor, like you said, kind of like the over-the-ocean landing sites and things like that as well.
Yes, because a shuttle couldn't launch unless it could land pretty quickly somewhere.
Yep.
So there were several transoceanic abort landing sites in Europe and Northern Africa during the course of the shuttle program. And at least one of those locations had to have acceptable weather for the shuttle to be able to launch. In addition, on launch day and of course on landing day, we were watching the other landing sites in the U.S., not only Kennedy, but Edwards Air Force Base and White Sands, in case on launch day there was an abort once around contingency possibility. And of course on landing day, we were watching all the U.S. sites for the landing weather.
Okay, so you guys were kind of all over the map with shuttle. Well, let's move a little bit forward and get into what you guys are working on today. Now our astronauts are launching and landing on Russian Soyuz vehicles.
Right.
And I understand you don't do the weather calculations and predictions for those vehicles, but you are heavily involved in a lot of the logistics, getting people there and things like that.
That's correct. The Spaceflight Meteorology Group is forecasting for the en route forecasts when the NASA planes leave Houston to go to Kazakhstan to retrieve the U.S. astronauts that just landed on the Soyuz and then bring them back home. And for that reason, it's a long flight to go from Ellington Field near Houston to Kazakhstan. First, they go to Goose Bay, Canada. They stop and refuel. Then they go across the ocean to Prestwick, Scotland. And then from there to Kazakhstan, and then await the landing, load up the astronauts, bring them back, reverse their route, and come all the way back. So what the Spaceflight Meteorology Group does is forecast the weather that NASA plane will experience en route all the way from Texas to eastern Canada to the northern UK to Kazakhstan and back, to make sure that the weather will be acceptable, that the big storms won't be there, or if they are, what are the alternate locations or the alternate routes that the plane could take, and it has done that a couple of times.
So again, you guys are kind of all over the map, and I know we had some, a couple of maps up. What exactly are we looking at over here? I can see we got the whole world up right now.
Right here on the center screen is a weather map that shows the path in the blue line. That's the path that the NASA flight will take, or did take, and it will take any time that they go overseas to Kazakhstan. And it's going from Texas to eastern Canada to the UK to Kazakhstan, and then they reverse that going back. And the lines on the map are isobars, which are pressure lines, which tell us, the meteorologists, where the high pressure systems are, the low pressure systems are, the fronts, and things, and the moisture patterns where there might be rain or thunderstorms or snow.
Pretty much anything that could hold them up or impede their trip.
Right. So with our AWIP system, which is our National Weather Service system, we are able to superimpose the flight path on the weather map so that we can better predict the weather, and then we create a graphic based on a simplified version of that we send to the flight crews and the mission managers, so they can also see at a quick glance what kind of weather patterns this plane will be experiencing as they go over and come back.
Okay, well now I want to jump into the future of the Spaceflight Meteorology Group. You guys protected all of America's space fleet in the past, and you're also going to be looking out for its future spaceship Orion. Tell us about some of the work you're doing for them.
Orion is the next human spaceflight program that NASA is pursuing, and SMG has a couple of areas that we're doing for support. First, we're consulting with NASA on the weather flight rules and the instrumentation that will be necessary for a successful flight. Since Orion is planned to land in the Eastern Pacific, that will be a much different situation than the shuttle, which landed on a runway. So we've been investigating things like wave heights and how to get weather data in an area where there is no weather data, and upper air data in an area where there is no upper air balloons. And so we've been in a consulting role for that. For Orion Flight Test 1, which is scheduled for 2 years from now, which would be mid-2014, we will be providing operational support here at SMG for the actual landing in the Eastern Pacific so that the right decisions can be made both for launch and landing for that test flight.
Okay, so watching the skies, you know, for our past astronauts and also looking out for our future spacecraft. We'll be sure to follow along, and we'll always hope for clear blue.